part-time. Who needs to go part-time? Me. Sure, it's me. You need to. I know. Have you met, me?
All right, what we're looking at today, and yesterday we did do some trinomials, and so some of the methods that we talked about yesterday will still be in play today, but we're going to talk about perfect square trinomials. We're going to talk about some binomials and what we can do when we have a binomial. And then towards the end of the lesson today, we're going to be given all different kinds of polynomials, and we're going to look at like what is the best method to factor that polynomial, and what's kind of the process that we're going to go through when we try to factor something. And so I'll kind of show you like a flow chart or a way to kind of organize our ideas on when and how we're going to factor something. So first of all, we're going to look at what we call a perfect square. Oh, be helpful if I spelled right. Trinomial. And on this one here, we could do the same thing that we did yesterday, right? Because you might look at this and say, well, I could just do the product and sum. And the product and sum would be perfectly fine here. Because we're looking at what multiplies to get 25 and what gives me a sum of 10. But what we're going to find out on some of these today is that when I look for the product and the sum of those two things, I end up getting the same number. Because if I said what multiplies to get 25 and adds to get 10, we would say what two numbers work? 5 and 5, right? And so here we would write this as x plus 5 and x plus 5. Or an even easier way to write this would be x plus 5 squared. And we saw that in the last chapter a little bit, and this is just a little bit easier way to write it. It's not wrong to write it like this. It's not wrong to write it like this. Either one of those would be fine, but the only time you can write it like this is when these two things are exactly the same. If you have exactly the same factor, you can write it as x plus 5 squared. We saw this in the last chapter. When I see this, if I was going to FOIL this out, I would write it out twice, and then I would FOIL it. And so once again, just like we've talked about over the last couple days, the way you can always check your answer here is, can I FOIL this to get back to here? Okay, and so if this number is a perfect square, then it could be a perfect square trinomial. Now, is it guaranteed to be, Shane?
Yes.
Always?
Oh, no.
Well, if we're not on our phone, we might know the answer to the question better. So, what about this one here? Is 36 a perfect square?
Yes.
Yeah, okay. So then our first thought was, oh wait, we could do 6 and 6, right? But does 6 and 6 make 13? No, 6 plus 6 makes 12. So if this was a 12 here, this would be a perfect square trinomial. And so that doesn't mean that this can't be factored. That just means that they're not the same terms. And so this would be more like what we did yesterday, where this is a perfect square, but 6 and 6 doesn't make 13. So then I would have to factor this and say, what multiplies to get 36 and adds to get 13. And so then this would be 9 and 4. 9 times 4 makes 36. 9 plus 4 makes 13. Okay, so just because this is a perfect square doesn't mean that these two things will always be the same. Okay, it could be, maybe, right? But not always. Today we're going to see, because that's what this section is dealing with, is we're going to see problems like this more, the perfect square trinomials. But that doesn't necessarily mean, as we go forward, that it's always going to be the same number. One over here, we had a plus sign in the middle. On this one, Another one. M squared minus 18m plus 81. If the last term is a perfect square, then that would be the first thing that I would look at, okay? Is 81 a perfect square? Yeah, if I take the square root of 81, I would need to get a nice whole number, right? And hopefully we kind of know some of those perfect squares, like at least the first 10. We got 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49. Those numbers, when I see them, I should recognize that, yep, that's a perfect square, okay? And the square root of 81 is 9. And does 9 and 9 make 18? Yeah, okay? So this would be a perfect square trinomial. The only difference is we have a minus sign in the middle. So we're going to do m times m is m squared. And in this case, they both have to be negative. And 9 and 9 are the two numbers that make this work. And then, like we said before, you could also just write it as m minus 9 squared. Okay? If you don't want to rewrite it like this, that's okay. You could just leave it like this, m minus 9 times m minus 9, but this would be a little bit simpler way of writing your answer. Okay, so either one of those would be totally acceptable to do. We saw some yesterday. Where we had a number in front. And when we had a number in front yesterday, we said, oh my gosh, we've got to do slide and divide, right? Well, the good thing today is that we don't necessarily always have to do slide and divide. If I look at the first term and the last term, if those are both perfect squares, the first thing that I should try before I do slide and divide is, are they perfect squares? Okay? And if I was going to do this, 25 is a perfect square, 9 is a perfect square. So both of those are good, okay? To get 25u squared, I would do 5u times 5u, because it is a perfect square. Okay, to get 9, I would do 3 and 3. What kind of sign do I want in between here? Both negative, okay? And what we should do is we should always check to make sure that it's going to make negative 30. Well, if we wonder where does that negative 30 come from, that's going to be the outside and the inside terms. So if I do 5u times negative 3, that would be a negative 15. If I do negative 3 times 5, that would be a negative 15. And if I do negative 15 and negative 15, then it gets me negative 30. Okay, so if I fold these together, then it would work. And once again, if you wanted to, you could just do 5u minus 3 squared. Either one of those would be okay. I'm not going to say you have to write it one way or the other. Either one of those would be acceptable, like on a test or a quiz. Okay, but you do want to make sure that it does make the middle term. Okay, if it doesn't make the middle term, then something's wrong. Another one that's a little bit different, and we saw one like this a little bit yesterday, is if we have a second variable in the mix. You're going to have a few like that today, where you're going to have a second variable in the mix. And the first thing that we're always going to check today, because that's kind of our new thing, are both of these perfect squares. Not necessarily the middle term, but are the first term and the last term perfect squares. Okay? And is 4 a perfect square? If I take the square root of 4, do I get a nice number? No. Yeah. Okay. What about 49? Yep. Okay. And as long as these are squared, then they would be perfect squares as well, as far as the variables go. So as we start to kind of set up our parentheses here, 4p squared would become 2p times 2p. 2p times 2p is 4p squared. Okay, then we look at the last two terms. 7q times 7q. So this one we got to include the q along with the 7. And then we look at the sign. As long as we have a perfect square trinomial, if this is positive, these will both be positive. Up here, this one was negative, so these were both negative. So in this case, this one is going to both be positive. Okay. And then we just want to make sure that the middle term still comes up, right? If I take 2p times 7q, it's a little bit weird, but 2p times 7q would be 14pq. This would be 14pq. And it doesn't matter what comes first, the p or the q, right? If I say 14qp, that's the same as 14pq. Order doesn't necessarily matter there because it's multiplication. And so 14 and 14 would make 28. And so if I wanted to, I could rewrite this as 2p plus 7q squared. And either one of those would be okay. Okay, so those are what we call perfect square trinomials. First of all, it has to be a trinomial, okay? And they both, the first term and the last term have to be perfect squares. Okay, another one that we're going to do that's very, very similar to this is what we call DOPS. DOPS stands for difference of perfect squares. First letter. But it has to be a binomial. So we can only do DOPS when it's two terms, when it's a binomial. And it's still going to be perfect squares if we can do DOPS. So if we look at a real easy one here, x squared minus 49. The biggest difference here is there's no middle term. There's nothing between the x squared and the 49. These are still perfect squares. But the difference, we call it difference of perfect squares because they're both perfect squares and we're taking the difference of it. It's a minus, okay? Difference means to subtract. So x times x gives me x squared. 7 times 7 gives me 49. But I need one to be positive and one to be negative. And when I do one of each, then if I did FOIL with this, this would make positive 7x. This would make negative 7x. And what happens when I have a positive and a negative 7? They just disappear, right? And so there is no middle term. That's why there's not a middle term here, is because those two will disappear. So if I FOILed these two, it would give me back to x squared minus 49. Can I write this as something squared? Are these two parentheses exactly the same? No. Okay. So the only time we can do the squared part is if both of them are x plus 7 or both of them are x minus 7. If one's different than the other, one's positive and one's negative, then we can't write this as squared. Okay? It is the same two terms, but the sign changes, and so that's why we can't write it as squared. So on this one, we would have to just leave it like this. We can't do it with the squared like we did on the others. Okay? 25y squared minus 36. Are they both perfect squares? Well, 25 is a perfect square. 36 is a perfect square. We got a minus sign in between. So that's all good news, right? Difference of perfect squares. I always like to set it up as just writing out my two parentheses and then just doing your square root. The square root of 25y squared would be 5y times 5y. The square root of 36 would be 6 times 6. And because we have a negative 36, one's got to be positive and one's got to be negative. And it doesn't matter which one's which. You can put the minus first if you want to and put the positive second. Order doesn't necessarily matter there. But once again, don't write this as something squared because the sign is different and so we can't do anything else with that, and that would be as far as we can go. Okay, this one's just slightly different. Still two terms. And the question here is x to the fourth a perfect square? Is there something I can multiply by itself to get x squared? Or x to the fourth, sorry. Yeah, which would be x squared. Because going back to our exponent rules last chapter, if I take x squared times x squared, we're going to add the exponents together, and that would give me x to the fourth. And we know that 16 is a perfect square. So we get that. Now here's where we got to be careful, okay? Because we had x to the fourth to start with, when we do these problems today, we're going to have to make sure that we simplify it as much as we possibly can. Is this a difference of perfect squares? What's the first word in DOPS? Difference, right? We need a subtraction sign here, and this is an addition sign. But this one is DOPS, right? Because we have a minus sign. Both of these are perfect squares. So what we could do here is this could break down even further. I can't do anything with the x squared plus 4, so that one is just going to move straight down. It's going to stay because we can't do anything with it. But x squared minus 4 can factor. X times x is x squared. 2 times 2 is 4. One's positive and one's negative. Okay, so you got a couple of steps on that one. If we stopped right here, then we're not quite there yet. Okay, that's not quite, we're going to try to factor it as full as we possibly can, and this isn't quite there yet. So we got to go one step further. And so sometimes we might be done here. Okay, as you look at this, if it doesn't have a square on it, then we're probably done, right? Unless there's a GCF or something that we can take out. But if it still has a square on it, check to see, is it a perfect square or is it DOPS that we can do? Okay, there's one other one I'm going to show you here, and I will tell you this, we probably won't see very many of these. But it is one that shows up sometimes, and it's a little different, okay? This one is different than any others that we do. And I show you this more for just being exposed to it, and I think you probably saw this a little bit in Algebra 2 as well. This is different because two things. It is cubed, and it's addition, okay? So we call this one the sum of two cubes. It's addition sign, and both of these are perfect cubes. If I took the cube root of them, they would be perfect cubes. Now, the factor for this is going to look really, really weird, okay? And so the way that I always learn this, and you guys probably learned this last year as Psalms. Okay, and you might remember you guys remember hearing Psalms before? Kinda, sorta, maybe? Anybody? Yeah, Shane? So you want to come do it?
Oh, no.
No? You're shaking your head yes. I'm picking on you today. Okay, you guys remember, kind of, Psalms? Not really? No? Nobody at all? No. So you guys, this is your Algebra 2 teacher's fault, right?
That's why we're in.
Okay, so here's what it looks like. This is why it's weird. You're going to have a binomial times a trinomial. Okay, the first part is easy. We're going to take the cube root of both of these. Okay, so we're going to take the cube root of y cubed. What times itself 3 times gives me y cubed? Y. Okay. What times itself 3 times gives me 64? 4. Okay. So it's not a square root, it's a cube root. Okay, we don't want to take the square root of 64, that would be 8. We want the cube root of 64, and you should have that button in your calculator, right? But 4 times 4 is 16, 16 times 4 is 64. Okay, 4 times 4 times 4 gives me 64. Okay, so that's my binomial. My trinomial, this is where the SOMPS comes into play. The first S says we're going to square the first term. The first term is y. So we're going to square y, and we get y squared. O stands for the opposite sign. So if this is a positive, this would be a negative. The M stands for multiply the two terms together. So we're going to take 4 times y, which is 4y. The P stands for simply plus, or this is always going to be a plus sign right here. And then the last S stands for squaring the second term. The second term is 4, so 4 squared is 16. And that's our answer, okay? And that's why it looks so weird, because here we had 2 terms. If I multiplied this times this, and that's something that we did in the last chapter, right? I would take y times all of these, I would take 4 times all of these, and I know it doesn't really look like it, and I'm not going to go through the time to actually multiply it, okay? But if you did go through the time to actually multiply this by this, and things would start canceling out, things would start disappearing, and all I'm going to be left with is y cubed plus 64, okay? And so the factor is a lot bigger than the actual polynomial that we started with. And that's the part that's a little bit weird about that, okay? That's not one that we're going to spend a ton of time with, and we're not going to see that one a ton, but it is another type of factoring that we might see. Okay, the last couple things that we're going to do here is we're going to talk about factoring any method. Where I'm going to give you a polynomial, and we're going to talk about all the different types of methods that we've done over the last 2 or 3 days. The first thing, and I'm going to put up a kind of a flow chart here. These are the kind of things that we're going to go through. Every time I give a polynomial and it says factor, then these are kind of the steps that we're going to go through. Step 1, what's the first thing we always look for when we factor? No matter what. GCF, okay? It could be 2 terms, 3 terms, 4 terms, whatever. I know I haven't really talked about that today, but none of the ones that we did today yet have had GCF in them. But that's the first thing you would always look for, okay? So first step is always GCF. Once I've done the GCF, or at least looked for the GCF, then we have to decide. And whether I take a GCF or not out, I still have to see if I can factor it any further. Okay, sometimes GCF might be it. I might be done. But if I do take a GCF out and I have 2 terms, I could still go here. If I don't take a GCF out and I have 2 terms, I could still go here. So these are the 3 different types of polynomials that we've talked about. 2 terms, 3 terms, and 4 terms. If I have a binomial, it could be DOPS, or SOMPS. But like I said, we're not going to see SOMPS very often, so probably DOPS would be the go-to here, and that's why I list it first. Okay, for a trinomial, we're going to look to see if it's a perfect square first, because that would be the easiest possible way to do it. If it's not, then we're going to go to what we did yesterday. Can I do product and sum? Or, if not, I may have to do slide and divide. And I'm going to do slide and divide if my a value is bigger than 1. My leading coefficient, the number in front of x squared, is some number bigger than 1. And that's what we saw yesterday. Okay, and then if it's 4 terms, we did that on the very first day on Monday, and that is grouping. If we have 4 terms, we could do grouping. Okay, so those, and what that does is that just kind of organizes it, right? If I have a trinomial, I'm going to go here, and then I'm going to go here. If I have 4 terms, I'm going to go here, and then I'm going to go here. Okay, so I don't have to I'm not going to use every method on every single one. It depends on what type of polynomial we have as far as what one we're going to do. Because you're going to have some problems today towards the end of the assignment that are just going to say factor. And you're going to use any of these methods that are in play. So the beginning of your assignment today will be the perfect square trinomials and the new ones that we talked about. And then towards the end, it'll say solve or factor using any method available. So let's look at a couple of examples. R3, it's a trinomial. So we try perfect square trinomial first. First thing, when I look at this, what's the first question we're going to ask?
Why is it so low?
Do what?
Is there a greatest common?
Is there a greatest common factor? Okay. Is there a greatest common factor? Okay, let's look at numbers first. 6, 5, and 12. Any numbers we can take out of 6, 5, and 12? No. What about x's? 5 x's, 4 x's, and 3 x's. Can I take some x's out? 3 of them. Yep. So I'm going to take x cubed out. Okay, what about y's? Can I take any y's out?
Yeah.
Yeah, how many? 1. So x cubed y is what we're going to take out. Okay, so what I have left, remember we're dividing by x cubed y. So we're going to be left with 6. I had 5 x's, I take 3 away. I had a y and I took it away. So that's all we got left. 5 is going to stay 5. We had 4 x's, we take 3 away. We had 2 y's, we take 1 away. And finally, we have 3 x's, we took them all away. 3 y's, we take 1 of them away. And we get to there. Just because I take a GCF out, does that mean I'm done? Not necessarily. Okay, it'd be nice if we were, right? But maybe sometimes we are and maybe sometimes we're not. But we got to check to see if we can do anything else here. Okay, they're not perfect squares, so perfect square trinomials out. And because we have a number in front of x squared, then we can't do product and sum. So we can't do perfect squares, can't do product and sum. So we're going to check slide and divide. 6 times negative 12 is negative 72. My sum is 5. Is there anything that multiplies to get negative 72 and adds to get 5? And the good thing is there's not. Okay, so we can't do any of those. Okay, and that's where you would kind of make your chart. Okay, try all the things that go into 72. There's a lot of things that go into 72. Okay, but you would have to check that just to make sure you can't do anything else with it. Okay, so this is as far as I can go, and we'd be done. Okay, let's try this one. First question, do we have a GCF? Anything we can take out?
Yeah.
What would it be? Okay, 2 goes into 4. Yep. 2 goes into 28. 2 go into 49.
72 equals 49.
72 equals 49.
No, 7. No, it is. 7.
So in order to go into, we have to divide by it evenly, right? So you're right. 7 times 7 is 49, but not 7 times 2, right?
That's close.
Okay, so no GCF. And so now we're going to look at our next step. And this is where we go back to, is 4x squared a perfect square?
Yes.
Yep. What about 49?
Yes.
7 times 7, right? So let's try it. 2x and 2x. 7 times 7 is 49. What kind of sign would we put? Okay, this is a positive, right? But because this is negative, we need both of these to be negative. So if the middle term is negative, we need both of these to be negative. And so we would do negative and negative. Okay. Does it work? Well, 2x times 2x, we already know that works. Negative 7 times negative 7 is 49. But then let's try the middle term. 2x times negative 7, negative 14, right? Negative 7 times 2x is negative 14. Negative 14 and negative 14 makes negative 28, okay? And this is one of those where we could leave it like this, or we could write it like that. Okay, good thing, bad thing is there a lot of work to show on these problems today? Really, okay? And the same thing's going to hold true for the test next week. There's not a lot of work to show here, really, right? You're not solving an equation or doing multiple steps. You're kind of doing multiple steps, but there's not a whole lot of work to show. You're just kind of going through the process of knowing how to factor. And that's maybe the hard part here. Okay, let's do one more. 5y cubed minus 65y squared plus 60y. Okay, first thing we always look at is how many terms we have, which is 3, okay? And that doesn't necessarily matter for our first step, but our first step's always a GCF. So now, do we have a GCF here? Yes. Okay, so we're going to take out a 5 and a y, but we can only take out one y. So if I take out 5y, I'm left with y squared. Okay, 65 divided by 5. 13. And then 60 divided by 5? 12. And the y disappears. Okay. Just because I take something out doesn't necessarily mean I'm done. It could mean I'm done, right? Sometimes GCF is all we can do. Is 12 a perfect square? No. Okay. It's not one of our perfect squares. Okay. So we can't do perfect square trinomials. So now we're going to try product and sum. Is there anything that multiplies to get 12 and also adds to get negative 13? What'd you say, Zach? There you go. Okay. Now, the first thing you got to remember is this 5y has to come down here. It's part of my factor, right? So 5y comes here, and then y minus 12, y minus 1. Okay? Remember that these two can be interchangeable. It doesn't matter if you write y minus 12 first or y minus 1 first. Those two are interchangeable. The GCF should always be listed first because we already took that out at the beginning. But don't forget to include that as part of your answer. Okay? So here we actually used a couple of different methods. We used GCF and we used product and sum. Sometimes you may only use one method. You probably won't use 3 methods. 2 would probably be the max that you're going to use. Once I break this down, that probably is going to be it. Okay, assignment for today. The one thing I'll tell you about factoring is the only way to get good at it is to practice. You've done factoring in both Algebra 1 and Algebra 2. And we're seeing it again here. Okay? It's going to be something that we're going to continue to see and need to be able to do. And in our lesson tomorrow, it is something that we will continue to use tomorrow as well. But we're going to take it a step further.